A straight segment OC of length L of a circuit carrying current I is placed along the x-axis. Two infinitely long straight wire A and B, each extending from z equals minus infinity to plus infinity, are fixed at y is equal to minus a and y is equal to plus a respectively, as shown in the figure. See, all the details which we have read out now is everything is present there in the diagram. You can see OC as one element, and along that the current is flowing. They have mentioned about it. A and B are extension where you have it along minus infinity to plus infinity, and it is along the y-axis. Everything is shown. If the wires A and B each carrying a current I into the plane of a paper, obtain the expression for the force acting on the segment OC. So if there is a current carrying through these wires, no, there will be a force acting on the wire element OC also. So what is that force acting on the segment OC? You have to find it. That is the first one. Then what will be the force on OC if the current in the wire B is reversed? So if the direction of current is reversed, what happens to the force on OC? We are supposed to calculate. Now for that, let us consider that let us see that you have a small element of thickness dx. We will consider a small element on the wire. Okay, so on the wire we consider this small element. We say that this small element is dx, and this dx is at a distance x from the origin. So this we are considering. Now at this point, if this is the x at the point, see, on the y-x-axis you have no, so the coordinates of this point will be x0, 0, and the magnetic field due to that point will be equal to, we'll call this as BA. BA will be equal to mu naught I by 2 pi r. It is because the wire carrying current, the magnetic field around a current carrying wire, you will be having this equation mu naught I by 2 pi r. Similarly, at point B also, at A and B, both the points we will be having magnetic field. At the point B, that is B, B will be equal to once again mu naught I by 2 pi r. Now these are the components of BA and BB. Along x-axis will cancel, because see here along x-axis both the magnetic field will be acting along different direction, like it will be acting exactly in the opposite directions, and those two gets cancelled each other, whereas along y-axis they add up to give the total magnetic field. So the total magnetic field B will be equal to twice of 2 into mu naught I divided by 2 pi r, okay, into cos component, no, it is, so cos theta. Now this we will simplify it. So when you are simplifying it, cos theta will be equal to x divided by r. If you get a right angle triangle here, see, cos component will be equal to x by r. So you can write this equation for B as B is equal to 2 mu naught I into x divided by 2 pi r into r. X by r you are substituting here, so that this equation becomes mu naught I divided by pi into x divided by a square plus x square. So this is the magnetic field. If this is the magnetic field acting on it, there will be a force acting on it, and force will be equal to BIL sin theta, or you can say it at I into L cross B. So the force acting on the current element, we shall write that as for a small element, no, we'll write that as a df. So df will be equal to I into dl cross b. It is like I into b cross l or l cross b, you are writing it. So substituting for all the values, you get df will be equal to mu naught I square by pi minus x dx divided by a square plus x square. So dl cross b can be written as dl into b sin theta, and here theta is equal to 90 degrees, and so sin 90 becomes equal to 1. So you are not getting any sin component here. Now simplifying this, the net force acting, if this is the small force acting on that small current element, then the total force acting on the wire OC, so the net force acting on OC, wire OC, will be equal to F is equal to integral of dF. So substituting the value of dF here, F will be equal to, in this, mu naught I square by pi is constant, so we shall write it outside, mu naught I square divided by pi into integral of 0 to L, it runs from 0 to L, x dx divided by a square plus x square. And this, when you are simplifying it, you will get the value for F as F will be equal to mu naught I square by pi into integral value comes out to be ln of a square plus L square divided by a square, and this force will be acting along z direction. Okay, this is the force acting on the wire. Now the second part of the question they are asking here is, if the current is reversed, what will be the force on OC, they are asking. See, if the current in B is reversed, the magnetic field due to the wires will be only along x direction, and force on current carrying wire will be along x direction, will be 0. So here we have written one statement here. See, we have written here saying that y components cancel and x components are retained here. Okay, when you are resolving it, those are the things happening here. But when the current B is reversed, no, magnetic field in both the wires will be only along x direction, and the force on a current carrying will be along x direction, becomes 0. So magnetic field will be only along x direction, and since the magnetic field is only along x direction, if since B is only along x direction, since B is only along x direction, you have F also, F along x direction becomes 0. So this is the answer for the last part.
Hi class, hi everyone. So class, just say this question. A long straight wire, parallel wire is 2 meters apart by perpendicular to the plane of paper. The wire A carries the current 9.6 ampere directed into the plane of paper, and wire B carries the current such that magnetic field at point P at a distance 10 by 11 from B is 0. Then find out magnitude and direction of a current in B. Okay, and magnitude and magnetic field direction in B, S, and force per unit length of the wire B. Fine. So class, first of all, see this diagram. This is the diagram of this question. Okay. So what we know, that net magnetic field at point B net will be 0. Okay. So due to the A, if you know the right hand thumb rule, then due to the A, magnetic field at P is around this direction. So the net magnetic field will be 0 only when, due to the B, net magnetic field will be this direction. Okay. Now class, just give it the name. Let us assume this is L and this is L1. Now solve first question first. Okay. So magnetic field at point P due to the A is equal to mu naught I by 2 pi d. Okay, so mu naught I by 2 pi L plus L1. Fine. Now magnetic field at point P due to the wire B is equal to mu naught I2. Suppose I2 is the current in point B by 2 pi alpha. Okay. Now the net magnetic field is 0. So mu naught I2 by 2 pi L1 is equal to mu naught I1 by 2 pi L0 plus L1. Fine. 2 pi cut itself, mu naught cut itself. I2 is equal to 10 by 11, which is equal to 9.6 divided by 2 plus 10 by 11. If you are going to calculate this, then you will get I2 as 3 ampere. Okay. What will be the direction of I2? Direction of I2 will be around positive axis. Okay. Around positive Z axis or outward to plane. Wire right answer good. Fine. Now part B. Find out magnitude of magnetic field at point S. Okay. Yes. So class, first of all, see this direction 2, 1.6 and 1.2. So this is right angle triangle. What? This is right angle triangle. And due to the wire B, magnetic field attaches around this direction B, and due to the wire A, magnetic field is around this direction, and due to the wire B, the magnetic field is around this direction, BB. Okay, and we all know the distance, so I think it's not a big problem to solve. So magnetic field attached due to the A is equal to mu naught IA divided by 2 pi. So value of this, let us assume this will be LA. Okay, pi LA. Now just put the value mu naught to 9.6 ampere divided by 2 pi into LA will be 1.6. So after calculating it, you will get 10 into 10 to the power minus 7 Tesla. Right? Now magnetic field attached due to the P. Okay. So mu naught IB divided by 2 pi LB. Just give the name LB as 1.2 meter. Okay. LB. Then it is 4 pi into 10 power minus 7 into IB. What is the value of IB? 3. 2 pi into 1.2. When you are going to calculate it, then you will get something else. 5 into 10 power minus 7 Tesla. So B net, and we know that class here, direction between magnetic field is 90 degrees. See, this is a right angle triangle, and direction between magnetic field is 90 degrees. So B will be BA square plus B square. Okay, fine. So root under 5 square plus 12 square to 10 to the power minus 14. So you will get as 13 into 10 to the power minus 7 Tesla. Fine. So this is the part B answer. Now part C. Force per unit length on wire B. So class, we all know force per unit length. Force per unit length will be mu naught I1 I2 divided by 2 pi d, where d is the distance between the wire and here d is the distance is 2 meter. Okay, and we know the value of I and IV, so I don't think it is difficult to calculate. 4 pi into 10 power minus 7 into 3 into 9 divided by 2 pi into 2. So after calculating this, 2, 2. Okay. Now when we are going to calculate it, then we will get something as 2.88 into 10 to the power minus 6 Newton. Okay. So this is the answer of part B. So answer of part A is 3 ampere. Answer of part B is 13 into 10 power minus 7 Tesla, and answer of part C is 2.88 into 10 power minus 6 Newton. Okay class, hope you all understand that. Thank you. Thank you everyone.